Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy, Subject Code 22626, Unit 5, Tariff and Power Factor Improvement. So what mean by power factor we will see here. So the definition of power factor is in AC circuits there is a phase difference between voltage and current. So here you can see in this figure we have plotted the phasor diagram. Here we have taken a reference as a voltage and we have taken a current. So the relation between the current and voltage is given. So there is a difference of angle of phase phi. So this is known as the power factor and it is defined as the cosine of the angle between voltage and current. So in an inductive circuit, the current lags behind the applied voltage and the power factor of the circuit is the lagging. So in this case, there is a voltage and here is the lagging of the current here. So the voltage current is lagging. So this is the inductive and it is known as a lagging power factor. And same in the capacitive circuit, the current leads the applied voltage. So if the current is drawn over here in the above hemisphere, so this will be a capacitive circuit and it will the current leads the applied voltage and therefore the power factor of the circuit is leading. And considered an inductive circuit which draws the current from the supply means lagging supply voltage and by an angle phi. So the current is resolved into the two components and it will form the reactive and in phase component and the reactive component. So this is the power factor given over here, and the disadvantage of the low power factor is so the cross section of the conductor increases. So the cross section of the conductor is proportional to the current and it is directly proportional to the inversely proportional to the power factor. So as the power factor reduces, current increases, cross section of the current conductor increases, hence its cost increases. Design of the supporting structure. As a power factor reduces, cross section of the conductor increases, so its weight increases. To handle this weight, design of the supporting structure become heavier, so its cost increases. Next is the cross section of the terminal increases. So as the power factor reduces, current increases and hence the cross section of the switchgear bus bar, contacts and terminals increases, so its cost increases. Next disadvantage is copper losses increases. As the power factor reduces, current increases, so the copper losses increases. As an effect, efficiency reduces. Copper losses is proportional to the current square and it is inversely proportional to the power factor square. So next is the voltage drop increases. So voltage drop is directly proportional to the current and current is inversely proportional to the power factor. So as power factor reduces, current increases and therefore the voltage drop increases. So regulation becomes poor. 6 is the handling capacity of the equipment reduces. So handling capacity, that is kilowatt of each equipment such as the alternator transformer reduces as power factor reduces. Seventh is the high kilovolt ampere rating of the equipment required. So kilovolt ampere is proportional to the current, and as we discussed, current is inversely proportional to the power factor. As power factor decreases, kVA rating of all equipments increases so that its cost increases. So kVA rating is proportional to the current and it is inversely proportional to the power factor. Cost or unit increases. From all the above disadvantages, it is seen that the cost of generation, transmission and distribution increases. Also, its performance, efficiency and regulation reduces, so that cost or unit increases. Next is the advantages of power factor improvement. If the power factor is improved, the current in the system for the same work is reduced and current is equal to W divided by power factor. Second is the reduction in the current reduces. So the cross-sectional area of the conductors and lines, reduction in the conductor size reduces the weight of the line. Next is the, if weight of the line reduces, supporting structures are of low capacity can be used. Also this reduces the cost. Next is the efficiency increases, so regulation decreases. In short, the advantages can be summarized as reduction in the load, energy losses in the system are reduced, increases voltage level across the load, increases the efficiency, reduces the line losses, better voltage regulation, reduction in kilovolt ampere capacity of the machines. Overall benefits in the cost. Next is the causes of the low power factor. So first is the magnitude of the magnetizing current I mu. As magnetizing current increases, power factor reduces. Second is due to the use of induction motor, most of the industrial drives, agricultural pumps, lift, irrigation pump, set uses induction motor which works at lagging power factor and so power factor reduces. Due to use of transformer, all transformers work at lagging power factor, so power factor of the system reduces. Next, due to the welding transformers are operated at low power factor which reduces the power factor of the system. Next is due to the inductance of the transmission and distribution line. In case of AC transmission and distribution lines, inductance is present, which the main causes of the low power factor is. Next is the series reactor. So the series reactor is used in the substation to minimize the fault current, causes the low power factor. Industrial electrical heating furnaces, so induction and arc furnace used in steel manufacturing industry works at the low power factor. which reduces the power factor of the system. Next is the arc lamp. So arc lamp and electric discharge lamps operates at the low power factor. So power factor of the system reduces. Equipments operated at light load. So the power factor falls if the equipment like alternator, transformer, induction motor are not operated at the full load. Then last point is the improper repairs and maintenance. So power factor falls if proper maintenance or repair of the equipments are not done. So the all AC motors except overexcited synchronous motor and certain type of commutators, motors and transformer operate at the lagging power factor. So the power factor falls with the decrease in the load. For example, in the induction motor has a reasonable higher power factor of 0.85 at full load, 0.8 at 75% of full load, 0.7 at half load, 0.5 at 25% of full load, and as low as 0.1 on no load. So the power factor at which motor operates falls due to improper maintenance and repairs of motors. In repaired motors, less wire is sometimes used than the originally wound motors. Therefore, in such motors, leakage of magnetic flux increases and power factor of the motor decreases due to the large magnetizing current. And due to increased supply main voltage, which usually occurs during low load periods such as lunch hours, night hours, the magnetizing current of the inductive reactance increases and the power factor of the electrical plant as a whole comes down. So there is a types of load and their power factor. So incandescent lamp, it is having 0.98 to 1. Then fluorescent lamp is having power factor of 0.6 to 0.8. Neon lamp used for advertisement, it is having 0.4 to 0.5 power factor. Then arc lamp used in cinemas is having 0.3 to 0.7 power factor. Then fans, it is having 0.5 to 0.8. Induction motor 0.5 to 0.85. Fractional kilowatt motors 0.4 to 0.75. Induction heaters 0.85. Resistance furnace 0.6 to 0.9. Arc furnace 0.85. Induction furnace 0.6. Arc welders 0.3 to 0.4. Resistance welders 0.4 to 0.75. So in case of worn out bearings, the rotor may catch at the stator. So some metal is sometimes removed from the rotor by turning instead of replacing the defective bearings. In doing so, the length of the air gap between stator and rotor increase, due to which greater magnetizing current I mu is increased and it is required, and therefore power factor drops. So the induction furnaces such as arc and induction furnaces operate on very low power factor. So these are all the causes of the low power factor. So we need to improve the power factor. So for improving the power factor, as it is having a lot of disadvantages and there are costs, So thank you.